Hello class, in this video we're going to learn how to compare data distributions. The learning intention of this video is for us to learn how to interpret and compare datasets that are displayed in a back-to-back stem leaf plot as well as datasets that are displayed in a parallel box plot. A back-to-back stem and leaf plot are essentially two stem and leaf plots that are displayed back-to-back with respect to one another. As you can see in the example down below, notice that both of these datasets share the exact same stem, but the leaves go in opposite directions. Another thing that I'd like to draw your attention to is that the datasets that are displayed on the left-hand side of the back-to-back stem and leaf plot is sorted backwards. So therefore, the way that you'd interpret this value over here is 12 as opposed to 21, and this value over here is read as 18 as opposed to 81. The reason why back-to-back stem and leaf plots are so useful is that this allows us to quickly visually inspect and compare what are the two shapes between the two distributions. It allows us to also quickly identify what are the centers, what are the spreads, and what outliers exist between the two datasets. As you can see by my notes over here, notice that I've highlighted both the median and IQR, and the reason why I've underlined these words is that these are the preferred ways in which we would therefore comment on the centers as well as the spread between the two datasets. Because the objective of this video is for us to compare two datasets, it's really important that you need to include the following three things in order to make these comparisons. The first item on the list is that we need to specify the numerical values for the median, the interquartile range, and the outliers. The second thing that you would need to do is incorporate the context when you're writing your report, when you're comparing the two datasets. And finally, please ensure that you're using comparative language, so things such as greater than, smaller than, in contrast, whereas, and you also want to quantify how much this particular value is greater or smaller than compared to the other dataset. Let's go through a few examples so that you can see how to structure your report. In this example, we need to write a report where we need to compare the dataset in terms of the center, the spread, and finally to write an appropriate conclusion. One thing that I want to draw your attention to is the statistical measures shown below. Normally, a back-to-back stem and leaf plot won't provide this for you and you will need to calculate this, but for now, let's just focus on how to structure your report. In terms of the center, you will need to compare the median values between the two datasets. So in this example over here, we can see that the median value of male life expectancy is greater in 2010 than it is in 1970. When we're writing this down in our report, I want to remind you that we need to include the numerical values, we need to include the context, and we need to use comparative language. So in my answer, I've said the median of male life expectancy in 2010 equals to 76 years, which is 9 years higher than the male life expectancy in 1970. When we're commenting on the spread, this means that we need to comment on the IQR. So let's examine the interquartile ranges between the two datasets. Notice that the interquartile range in 1970 is larger than the interquartile range in 2010. So therefore, I'm going to say the spread of male life expectancy in 1970 is greater by 4.5 years than the spread in 2010. And finally, to write a conclusion, we simply need to write an overview or a summary between these two dot points over here. So therefore, I'm going to say that in conclusion, the median life expectancy has increased, whereas the variability in life expectancy has decreased since 1970. So this is how you should be structuring your report when you're comparing two datasets. Let's now look at a more complex example. So in this example over here, notice that it doesn't provide us with the statistical measures, but we still need to comment on the center, spread, and write an appropriate conclusion. So the first thing that we're going to do is now find out what is the median of both datasets. So on the right hand side, I'm going to show you the working out of how to do this for the datasets shown on the left. So remember, to find out the median, the way that I tend to do things is I use the formula n plus 1 divided by 2, as this will tell us the median position. So in this particular dataset, there are 16 values. So therefore 16 plus 1 is 17 divided by 2 gives you an answer of 8.5. And this tells us that the median value lies in between the 8th and 9th number in this dataset. So if we count it, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore it's going to lie over here. As a result, the median value is going to be equal to 68.5. Let's now do the same thing to find out the median for after exercise. So again, 16 plus 1 is going to equal to 17, divided by 2 is going to equal to 8.5. So similarly, the median value can be found in between the 8th and 9th term. So again, 1, 2, 3, 4, 5, 6, 7, 8, 9. So therefore, our median value is going to lie in between 82 and 84, which in this case corresponds to 83. In order to comment on the spread, we need to find out what is the interquartile range. And since we've already found out that the median was equal to 68.5, therefore this is going to be the lower half of the data set on the left-hand side. And therefore these values over here, which I've circled now, are equal to the upper half. What I'm going to do now in order to calculate IQR is find out the values of Q1 and Q3. So to find out the values of Q1, I need to find out the median of the lower half. And in this case over here, it can be found by finding the midway value between 57 and 61, which is going to therefore equal to 59 in this case. And to find out Q3, I need to find out the median of the upper half. And if you do this, you'll get an answer of 76.5. With these values, I can now calculate my IQR, so therefore my answer is going to be equal to 17.5. Let's now find out what is the IQR of a dataset found on the right-hand side of the stem and leaf plot. So again, I'm going to need to find out the values of my lower half as well as my upper half. And to find out the values of Q1, we find the median of the lower half. So in this example, it's going to be equal to 73.5. Whereas Q3 can be found by finding the median of the upper half, which in this case is going to be equal to 88.5. To find out the IQR, I'll find out the difference between these two values over here, which in this case will be equal to 15. Now that I've found out both the median as well as the IQR, I can now comment on the center as well as the spread. So in this example, we can clearly see that the median heart rate after exercise is significantly higher than the heart rate before exercise. So again, make sure that you include the context, make sure you include values, and make sure you're using words such as greater than or smaller than in your responses. So therefore, the way that I've responded is saying the median heart rate after exercise equals to 83 beats per minute, which is higher by 14.5 beats per minute compared to the heart rate before exercise. In terms of the spread, we can see that the IQR of the heart rates before exercise is a lot more larger compared to the IQR after exercise. So the way that I've responded was saying the spread of heart rates before exercise is greater by 2.5 beats per minute compared to the spread that's found after exercise. And finally, in terms of the conclusion, I just need to summarize what I've stated earlier on in these 2 dot points over here. So I answered by saying, in conclusion, the median heart rate increased following or after exercise and were less variable compared to the heart rates before exercise. The next part of this video is for us to look at parallel box plots. Parallel box plots are essentially multiple box plots that are displayed side by side one another. Just like a back-to-back stem and leaf plot, parallel box plots are very useful when we're trying to compare several datasets. It's important to note that when we're constructing parallel box plots, we need to label our number line, but we also need to label each of these box plots as well. Furthermore, I do want to say that you may also encounter parallel box plots that are also drawn vertically as shown over here. When we are comparing parallel box plots, similarly, we're going to need to compare these datasets in terms of their shapes, their outliers, their centers, as well as the spreads. However, you won't be required at all for year 11 to comment and compare the shapes of 2 parallel box plots, but please be aware that you will definitely need to know this for year 12. Before I go through an example, I want to quickly address a common misconception that I often see students make, and that's where they tend to comment on the amount or the frequency of outliers that are present in the dataset. So if you look at the example down below, notice that these datasets contain outliers. I often see students incorrectly say that this box plot contains 2 outliers and the box plot down below contains 1 outlier. The reason why this is incorrect is that a box plot doesn't actually tell us the frequency or how many values there are in the overall dataset. So as a result, this statement is incorrect. Instead, this just tells us that any values that's equivalent to, in this case, 48 and 51 are referred to as outliers. It doesn't tell us how many outliers exist. Now that I have made you aware of this, let's now go through an example. So in this example, we're going to write a report where we need to compare the distributions in terms of the center, spread, and outliers. So what we're going to do first is we're going to look at each of these box plots in isolation and find out what is the median, what is the IQR, and what outliers exist. So for the very first box plot that you see on top, let's find out the median of that. So in this example over here, you're going to need to just kind of visually inspect and eyeball what that value corresponds to. So I'm going to say that the median for the first box plot is equal to 72. To calculate the IQR, I need to get my Q3 value and minus it from my Q1 value. So in this case, I'm going to go 80 minus 65, which is therefore equal to 15. And in terms of the outliers, I can see that there are no outliers, so I'll therefore say no outliers exist. For the second box plot, the median value is equal to 65. The IQR is found by going 70 minus 60, which is equal to 10. And in terms of the outliers, I can see that values equal to 40 as well as 120 are referred to as outliers. Now that I've obtained all the following useful information, I can now write a report to make a comment and compare the center, spread, and outliers. So in terms of the center, I'm going to say that the median pulse rate of females is greater by 7 beats per minute than the median pulse rate of males. In terms of the spread, I can see that the first box plot is a lot more varied. So therefore, I'm going to say the spread of pulse rates in females is greater by 5 beats per minute than the spread in males. The next thing for me to comment on are the outliers. So I'm going to say that there are no outliers observed in females. However, for males, there was a pulse rate of 40 as well as 120 beats per minute, which I consider to be outliers as they don't kind of fit the norms or the trends of the overall data set. And the last thing for me to do now is to write a conclusion. So I'm just going to say that the median as well as the variability, meaning the spread, in terms of the pulse rate for females were a lot more greater compared to the male counterparts. I would now like you to answer questions from exercise 2I to get further practice. This is the end of the video. Thank you guys for watching, and I'll see you guys again in the next one. Bye.